So let's take a look at another quick example here. I want to find the directional derivative of f of x equals y squared over x at the specific point where x equals 2, 3 in the direction of v equals 1 plus 2j by using the gradient vector. Now, the first thing you want to notice is that v is not a unit vector. So really, the very first thing we should probably do is find the unit vector. So I'm going to say u is equal to, obviously, v over the magnitude of v, which is going to be 1, 2 over root 5. So now that I actually have u, I'm going to say that the directional derivative is equal to del f dot u. Whoops, yeah. Well, I don't need that there. Del f dot u, which is obviously going to be equal to, let's do it over here, the partial of x, partial of y, dot, I'll go ahead and put the whole thing in here, 1 over root 5 and 2 over root 5. So obviously I need to find these partial derivatives at 2, 3. So I'm going to start off with a partial with respect to x. And that's going to be negative y squared over x squared. I need to evaluate that at 2, 3, which gives me what? Negative 9 over 4. And then I need the partial with respect to y. And that's going to be 2y over x. And again, I need to evaluate that at 2, 3. So that's, well, just 3. So now I have the gradient, del f. Del f equals the vector, there is negative 9/4 and 3. So what's the directional derivative? Well, the directional derivative is going to be negative 9/4 3 dot there it is, 1 over root 5, 2 over root 5, which is negative 9 over 4 root 5 plus 6 over root 5. So just doing a little bit of arithmetic, that's going to be 24 minus 9 over 4 root 5, which is then, what? This is 15 over 4 root 5. So this is the rate of change of z in the direction of this vector. Whoops. Yeah, it's in the direction of that vector, which obviously u is also in this direction. U is the unit vector that we needed to work with.